So this video is meant to go along with the lesson that we have covered today and serve as a review, help you as you go through your portfolio item that you need to complete. So below is the daily maximum temperature in degrees Celsius observed at Winterland, Newfoundland in July 1990. So summary of that data is that you have the mean temperature of 15 degrees, median temperature of 15 degrees as well, mode of 13, and standard deviation 2.5 degrees. You're then asked to sketch a normal distribution curve for this data. So with this data, if the data is normally distributed, then the mean and median will have to be the same number. The middle number and the mean would need to be the same, because when you look at the shape of the curve, the mean is always in the middle and the median is the middle number. So they would need to be the same. If this doesn't happen, then your data is not normally distributed. The mode was just included here from previous work that we had done, and it is not necessary in order to sketch a normal curve. You can compare it, but it's not necessary at this point. Standard deviation, though, will be needed. So what we need to help us with our curve is we need to know that the mean, so x bar, is 15 degrees Celsius, and the standard deviation, so the symbol sigma, is 2.5 degrees Celsius. So on your sheet, I've given you a grid paper to use and asked you to sketch it. What I will be looking for is that you reproduce a graph that looks like this, and you don't need to know the mean or standard deviation in order to do this graph. So this is a normal distribution graph, sometimes called a bell curve. So in a bell curve, your mean would always be here in the middle, and each of these points after will be for standard deviation values here along the bottom. So you can produce this curve without knowing anything else about the question. You draw the curve in, the percentages don't change. So within one standard deviation, the mean is 34% on either side, then 13.5 and 2.35, and then 0.15%. And since this is the middle, and this bell curve is what we call symmetric, you could fold it over on itself. After this middle point, you see that there's overlap here, that they would, if you folded it, that they would cross over. So to make your curve, just reproduce this one and then write in your values. So you have 15 degrees here, and if your standard deviation is 2.5, well, you're going up by 1 plus 1 standard deviation, so that means this value would be 17.5. At this line, you're adding on 2 standard deviation values, or you go up another 2.5 to 20, and 3 standard deviation values, you'd be up to 22.5. And as you work down this number line, you will be going down, so minus 1 standard deviation, or take that value off of 2.5, so you have 15.5. So it starts with a 15, and you're adding or subtracting your standard deviation value. And then you're down here at 10, so it's 2 standard deviations away. 3 standard deviations away would put you at 7.5. So standard deviation is meant a variation that you could expect. Although the mean value of the temperature in July might be 15 degrees Celsius, we certainly don't expect that every day is going to be 15 degrees. Some days are going to be a little warmer, a little cooler. And this bell curve is a way of just showing the amount of variation that you could expect. And if we're looking at this curve, if I go from the mean, and I look on either side, so from the mean up or down. If you add your percentages here, actually I go a little further up to include here, you would have 50% of all your values. So it would mean that half the days are warmer than 15 degrees, and here on this side, that half your days are cooler. So in total, if you include the extreme ends here, you have 100% your data. And then you complete the following table. So what percent of days have a temperature of 12.5 degrees or less? So you find 12.5 degrees, and here 12.5 degrees is here. So what percent of days are here? So from this point down, that's a matter of adding your values. So you look at the percentages. You have 13.5, 2.35, and 0.15. Or, if you add them together, 16%. Now, what number of days in July what are the number of days in July based on these temperatures? So 16% of the days in July have a temperature 12.5 degrees or less. What number of days would that be? Well, we know there's 31 days in July, and multiply that by 16%. So 16% of the days in July. Or 31, and you change your percent to a decimal. So you take your percent, divide by 100, you get 0.16. And quickly looking at that on your calculator, 31 times 0.16, and you get 4.96 days, which we would say 5 days. So that better helps explain or give you a picture of what July would look like that year. Did you have about 5 days out of the month that were pretty cool, less than 12.5 degrees, or 12.5 degrees or less. So what percent of days are between 12.5 and 17.5? So again, this is where you need to have your distribution curve. So between 12.5 and 17.5 would be here. Now if we look at that, well, you have 34% and 34%, or 68% of your days. So 34 and 34, and you would have 68% of your days are between 12.5 and 17.5 degrees. And what does that mean in terms of the actual days? So 31 times 6 times 68%, or 31 times 0.68. You have 21.08, and we would just call that 21 days. And then between 15 and 20 degrees, would be here. So that's 34 plus 13.5. Or 47.5%. So that's 31 times 47.5. So remember, you just take your percentage, divide by 100 to get it in decimal format. And you have 14.725. So we'll round that, because we're talking about number of days here, we'll round that to 15 days. And then what percent of days are higher than 22.5? Well, if you remember from our chart, that should be 0.15%. So very few of the days. So 0.15, here, so it's higher than 22.5 would be in this range, 0.15%. So we have 31 times 0.15%. Oops. Now, have to divide that by 100. So 31 times 0.0015. So the actual number of days, 0.465. Alright, so that doesn't even add to 1 day. Now that doesn't mean it's not possible. It's just, it will be extremely rare to have a day higher than 22.5 degrees for that month. Alright, so that takes care of that lesson. Thanks folks. Remember, if you have any questions, let me know.